Alright, time to dive into Chapter 5, designing using 2D alignments. We've entered Chapters 1 through 4 with some introduction into Civil 3D and some various things, the whole interface, how to use our raw data, how to use survey databases, how to use COGO points, how to use various things with surfaces and edit them, manipulate them, analyze them, annotate them, make our existing surface map in some ways, which will translate to designing maps as well. Now we're going to enter more into the realm of design, but also surveyors need to know how to use alignments very well too, sometimes even more than designers in certain ways that they need to replicate alignments for right-of-way plans for highways. They need to use alignments to dictate existing center lines and various things. So a lot of folks in the civil and the surveying side, civil engineering and surveying side, use alignments quite a bit. They are the backbone of many things. And we'll see that in a minute. So start by getting your Chapter 5 lab files, Revit, or excuse me, Civil 3D, and we'll open up alignment from objects to start, but let's go to our textbook and we'll begin talking about Chapter 5. So we're jumping into Chapter 5, which is on page 91, designing 2D alignments. So after we've gone through the existing conditions, we're going to start building the common way they say, and it's very industry known, is building design is to lay out a 2D version of key features through an alignment. We're going to get to know in these first couple areas what alignments are, to understand them, their geometry, what is typical, how to create alignments simply from objects, which leads us into the second part, creating them, and how to create alignments also using alignment creation tools in Civil 3D that make them very dynamic. Two different ways of creating them. One uses AutoCAD entities, objects, polylines, various things. The other one uses similar, but we create them from scratch using very dynamic Civil 3D tools. And the third part, we're going to edit alignments, and the fourth part, we're going to apply some design criteria files through AASHTO and some highway designs and check sets to check our alignment for speeds and design qualities. So jump into Chapter 5 and open up alignment from object drawing. Now, to understand alignments, they're basic road geometry that is usually a center line, not always. They can be a offset line. A lot of times they're center lines, of course, in this subdivision, in this land development. We're going to make these ones are center lines of roads, of course, but they don't always have to be that. They could be offsets, they could be on either side, but a lot of times they are the backbone of what makes up various things like roads, railroads, canals, channels, dams, and pipelines, various civil structures that are built along a common geometry that controls them, which a lot of times is an alignment. Bridges as well. So alignments are dynamic in Civil 3D. When you edit them, they edit many things that branch out from them, such as profiles, section views, profile views, and corridors, and various other things, and how they're related to other entities like even pipe networks. So alignments, we're going to find out, are made up of tangent or lines, curves or arcs, same, and spirals, which are basically curves with ever-changing dynamic radiuses. An arc or a curve is one set radius. A spiral is a dynamically changing radius, which a lot of times is used in highway design to make smooth curves so you don't fly off the road and you can transition well on highways and railroads especially as well. So we're going to learn how to create alignments from objects to start, and I'm going to branch off to some industry pictures to help you better visualize alignments when we get a little further along. Let's start with 5.1, alignment from objects. And we're going to do one of our simpler forms, and this is a good one to memorize. We're going to go to the Home tab and say alignment, create alignment from objects. This is taking from a selected line, curve, or polyline AutoCAD object, and it converts it, the graphic entity, those things I just said, to an alignment, and optionally adds curves in between if you elect so. So we're going to say that, And now we're going to select an object. It wants us to select the longest magenta polyline, which is Jordan Court here. Let's select it. You can't pre-select it. This one you have to select after you select the verb, the action. Select it. It is selected. Now let's hit enter, and a black arrow will appear. It says this is the direction you want your alignment to go. It's very critical. Your alignment will start at 0 here and its highest number here. That's a big thing. You might want to reverse it, flip it. I'm going to reverse it back. I didn't want to do that actually. So we can undo what I did. Let's start it one more time and say create alignment from objects. Select it. And this time I want it to go this way. So we want it to enter southward. We can hit enter. You can flip it though. I showed you how to flip it. So the choices here are very important. The direction after the direction alignment. We'll call it Jordan Court. Let's verify the type of alignment. Is it a rail alignment, miscellaneous? Is it a curb return where roads hit other roads? Is it an offset alignment, which a lot of times you will make offsets from the center? No, it is a center line alignment. And we'll start at 0, 0. We'll verify that for the site, no site is selected. We'll learn more about these later. Alignments and everything that falls under alignments, grading objects and parcels and feature lines can fall under sites. Sites are different ways to differentiate different developments from one another so they don't interact. We're going to keep it on none. We're going to go to proposed. That makes sense here. It's going to be a new built road. That's its default layer in the AutoCAD Civil 3D settings. No labels for the label set that labels it fully. We'll learn more about these later. And let's uncheck that. Otherwise it would default to these radiuses. That's saying we like what we drew here. These polylines, they're just what we want, and we'll accept that. It says to leave this so it erases entities. You might have some reasons why you want to keep this polyline. Then you would leave this unchecked so you create an alignment and the polyline stays. In this case, we want the polyline to go bye-bye. Hit OK. It all becomes an alignment. So now we cross box. So when I cross box with the green, right, my selection set, anything it touches, I'd verify I have one alignment, no polyline, just one alignment. My backbone started. So it wants us to talk about grips. So when you pick this alignment, see all these different grips? We have grips that can move this PT, and we'll talk about PI, PT. This grip can move here while everything stays somewhat tangent. We have grips that can change the radius to bigger or smaller. I'm going to hit Control Z to undo that. We have grips that do various things on alignment. And then if we go to these polylines, these magenta ones, they're regular Civil 3D polylines. They don't have that. They have more dumb grips, if you will. The blue regular AutoCAD grips of a AutoCAD entity that move kind of independent of one another. They don't have constraints, free, floating, and fixed to each other. They just move where you tell them to and draft them to in various ways. Same with this polyline. It's just saying, look at the difference. So this, you move these grips on these polylines, nothing stays tangent, meaning that one point doesn't have a common center point here. So I'm going to turn on my O snaps here, and I'm going to have the center one good. Okay, so let's say I draft a polyline. Just type in PL for polyline, watch it come up, and I'll hit enter to accept it. So to be tangent, these have to go parallel out. These go to the center line or center of the arc. We'll talk more about that in a minute. These are tangent. I'll go to the center. If I hover on this arc, I'll right shift hold just to get center, just for one command. I'll hover by the arc or the curve, See that grip pulled up on the, and now I got the endpoint. So a tangent would have common degrees here. This would be 90 degrees. 90 degrees. This is definitely not 90 degrees. So I'm moving things around differently. You can see that this alignment is tangent just by looking at it with some of that stuff I was doing. We can practice moving some of these grips around. We can make this radius bigger. You can see where these lines would meet would be called the PI, or the point of intersection. That's where theoretically they would cross. Okay, if this didn't have a curve in it, this would be the PI of the lines. This is a curve or arc in here, so it does not, it's not a PI to a PI, it has an arc or curve here. So this is the PI, this is the radius we're moving. We'll practice moving some of these grips. If you move this, it keeps it tangent. See how it's dynamically staying tangent? That did not happen here on this one. You move these, they move freehand from each other. That's a Civil 3D polyline. That's pretty critical. So as you make these alignments, various things happen to keep them dynamic. Tangent, the arc's tangent, the spiral's tangent to the straight lines aka tangent. So we're just talking a little bit about that. Now I'm going to undo a bunch of steps. What I did, I was just showing you how things move around dynamically with Civil 3D alignments compared to, say, polylines. And that's pretty critical to this chapter. I was just showing you some analysis. We're going to do the same thing. So, say, alignment, create alignment from object. We're going to do the same thing with Madison lane, center line. Enter. That direction's fine for just instruction purposes. We'll turn that off. Everything's fine, but we're going to call this one Madison lane. We can right click and say create alignments. So the last commands, this is handy. Or if you go to recent input, these are previous commands too. You can say let's do it again here, or you can go here. So if you hit right click, you can repeat the command. That's a handy tool. Or just go up here. I could say right click, now data click left click, and it does the same thing. I'll say that direction's fine to create the alignment. I'll call this one Logan Court. No curves added. So we made a bunch of alignments. That's the end of this area. We'll continue on talking about geometry. I'm going to close this one off. We're going to practice creating alignments using the alignment creation tools in Civil 3D. That's just using existing AutoCAD geometry, which is pretty cool. Sometimes a lot quicker. So now we're going to get to, let's talk about alignments a little bit. What makes them tick? So in order to talk a little more about them, let's pretend this road here has a centerline alignment. It might have offset alignments that are the edge of this road. Very well does. This is some advanced highway with large radiuses, with high speeds, super elevations, sloping it in certain ways, guardrails, ditches, canals, fences, split median with ditches in the middle. It has all kinds of stuff going on. Wide shoulders, not so wide there, but on one side at least. Signage, various things, a lot going on. It doesn't look so much, but when you start to actually draw and draft the design of these, there is quite a bit that goes into their geometry. If you're an enjoyer of geometry or like geometry, alignments in some Civil 3D design you will like, as well as surveying. So if we go back a couple steps in this picture, here's a simple alignment curve. So it starts by entering this direction. It goes into what we call a PC, a point of curvature, which in this case, let's assume it's tangent, which it is in this depiction, goes to a radius into this curve or arc that has a radius, which is this distance, half the circle, in this case arc, half of this arc diameter. And we have other things like this chord bearing here. If it went from PC to PT, point of tangency, that this would be the chord bearing, which also has a chord length. This is the tangent length. So if this curve and/or arc was not here, and these lines theoretically shot out and intersected, that would be the point of intersection. This is a simple curve, okay, it's our arc, aka both. This is the tangent distance, and this is the delta, but in this case it's going to be 90. This M, I'm not sure what that is, the mid-ordinate distance or something. We won't talk about that. Now when this curve goes around, it starts with the point of curvature, goes around, has a certain distance in station going up station, up in station going upwards to the point of tangency, where it re-meets to a tangent condition with the same arc, 90 degrees from this to this angle, 90 degrees from here to here. Point of tangency continues on tangent. That is a simple horizontal curve. It's a backbone to understand in Civil 3D and in land surveying, especially designing in Civil 3D and civil engineering. Get to know this. Simple curves is what we just learned. Has its PI out here, arc or curve, compound curve. It has one arc with one radius, no tangent or line in between. But they do stay tangent. It continues on to another arc or curve of a different radius. They go from one to another. Some people call those broken back curves. Broke back curves. They just continue. There's no tangent section. Those do happen in civil engineering and land surveying. They're not always preferable, but they do happen. A reverse curve, very similar. It enters in here to the PC, point of curvature. That's where it begins. PC, memorize that. Keeps going over and around to the PT, but in this case, it's the P point of reverse curvature, so PRC. Whereas this would be called, comes in, tangent, tangent, PC, just like this one. And then it goes around to another curve. This is the PCC, point of compound curvature. It's two arcs, broken back arcs on top of each other that are tangent. There's no line in here. These are hard to draft. You got to have some skills to draft these in AutoCAD. Same with these sometimes. This one comes around from the PC. If you theoretically extended these out, that would be the PI, right? Comes around. This would be the PT in a typical simple curve, but this is called the PRC, the point of reverse curvature. So similar to a compound curve, but it circles back the opposite direction. It reverses. And these both have one radius. All three of these have one radius. Which leads me to my last one, a spiral curve. Spirals are a dynamic radius. They're changing. They move. They are even harder to calculate and get used to. Civil 3D has some tools to do so. So this enters most normally in highways and railroads in a tangent, starts and goes to a point of curvature, to a curve, to a simple curve. Usually this is how spiral curves work. They start with a tangent, go into a simple curve to right here where they start into a spiral. Start a spiral, and this section here is the spiral. This is a dynamic, it's hard to tell on this one, it's a little bit small, a dynamic spiral. It's an ever-changing radius as it goes. So you go from tangent to a curve to a spiral. These happen on railroads especially a lot when they need really gradual long curves that change for such a long entity and with a lot of force. It's going through the spiral back to a curve. So this is a curve now. It's back into a simple one radius curve, enters, and back to the PT, the point of tangent where it's back to a straight line. So spiral curves are pretty interesting, but I've done a few of them in my career. They sneak up on you. Here's another one with some more annotations coming in. Point of curvature 1. If this was a straight line, this would be the point of intersection, but it's not. It's a curve. Here's some curve data. Used very common in surveying especially. You have, this usually would have a length of the curve, the actual physical length. Also has a radius. The length isn't here for some reason. The radius would be the distance to the center point, and the delta, 360 degrees in a whole circle. This is saying it's 31 degrees, 33 minutes, and 0 seconds of that 360. So it occupies that many degrees of a 360 circle. That describes a curve very typically. It's missing the length though. It goes back into a point of tangency, a straight line, to here, and then it starts another curve. This curve doesn't have a delta, so there's some missing annotations here, but this is kind of similar to how land surveying would look, and sometimes civil engineering has these annotations as well. Length, delta, and radius, describing a curve. Same again, this is a simple curve, but this is some additional nomenclature. You enter a curve, and you're going this direction. This is your back tangent. As you continue forward in stationing to your forward tangent. This is back and forward. This is where the PC is, point of curvature begin, and the PT, point of tangency, where the curve ends. So these we're not going to focus on much, but they are in industry a lot, which leads me back to this slide. You can see as we're going up this direction, the station is increasing. So we're at station 5 plus 30, 530 feet, let's say, or 530 meters. As we continue down to this PI, we're at station 9 plus 70, 970. They're going up station. So that is kind of how this is saying. This is in the back. This is further a lower number. This is a higher number in stationing. This is for later. We're going to talk about highway speeds related to tangent lengths. So basically, the faster the highway, the more tangent you might need in between curves. And the faster the highway, the larger the curves you will need. So Interstate 90, their minimum curve radiuses to the center are well over 1,000 in most cases, if not several thousand. They need a long gradual curve, big curve, so you don't fly off the road corner. So we'll talk about a little bit of that, and they need long tangents in between curves. They can't just have situations like this on super fast highways. All the time, reverse curves. They would need a huge curve going into another huge curve going the other way. A little bit of information, but there's some pretty fascinating stuff with geometry when it comes to alignments and civil design. So that'll lead me into exercise 5.2, alignment creation tools, and we're going to look at the blue geometry. And there's actually, before I continue on that, page 96 has some really good terminology. I prefer to talk about it with these images. Some things I didn't mention at the end of page 96 are free, floating, and fixed. So we'll learn about these a little bit. When something is free, a line, curve, or spiral, it's dependent on another alignment on both ends. So it's basically free to move on this end and this end. And then floating, it's free to move on one end. And then fixed, it is fixed here and here essentially. So 3 permutations on how you can free, float, or fix a curve or a tangent section as you move up or down in alignment. Those will come into play a little later. We won't dive into them too deep. We're going to jump into 5.2 exercise now. So it says look at these odd dimensions accompanying the notes. They're talking about where to put stuff. These are just, let's say a designer came in and said, I want these things to happen. This line has to be parallel to the property line. When this is the property line, some designer came in and we're going to do the final drafting. 150 feet away, room for one right away of lots. So he's trying to leave room here in this area for putting some lots. He wants to have a minimum distance, so that dictates this XY distance. And there's some other things. He wants this to be 90 degrees, but there has to be a curve in here. There's various things. He says, hey, or someone says, there's steep slopes in here, so we're going to have to avoid this zone. They want a certain design function saying this needs to be parallel to the property line ideally, but this distance away, so we can once again put lots in this land development. And various other little notes. We want this to come in perpendicular, so somewhat at a decent geometry here. There's a lot of geometry that comes into road, lot, and design. If you ever look at Google Earth, let's just go there real quick, and you can just see it. It's pretty evident just by looking at our city, Missoula, Montana. All this stuff didn't happen by accident. It was surveyed very precisely, engineered very precisely, with curves and radiuses. Even though some of these streets are a little crazy, you can just see their geometry, even with aerials on. If you turn on aerials, they're even more evident that what was actually built is very much at very precise geometries, really from a distance. You have this Orange Street here. There's a very tight curve in here. This isn't highway speed, but a lot of this stuff was laid in here very precisely from this kind of bird's eye view. There's a lot of curves and radiuses and various things going on. There's a lot of grid type roads too, of course. If you go all the way up to some of the more major arterial roads, some of the on and off ramps of this diamond intersection into the lower Rattlesnake, it's a little straight, but these are probably spirals coming into here. Gradual transitions as you get up to speed. Okay, as this highway goes around, this is a slight curve by Waterworks Hill, but it's huge. It's a huge radius. This curve is a little bit tighter, but that is a huge radius by Orange Street, for example. They're not small. And this is an 80-mile-an-hour highway now. This is one large geometric curve, as you can see here. So these are pretty prevalent everywhere you look on Google Maps of a well laid out highway, railroad, canal, various things. That might be of interest to you more than anything in this chapter, that this stuff gets applied to the real world when they get laid out by surveyors and civil engineers, and then later built by contractors. So that being said, let's jump into the Home tab alignment creation tools. And these are Civil 3D creation tools. They're going to come up. In this case, we're going to create an alignment more from scratch. We're going to call it Jordan Court. And we're just going to click OK. We're going to take all the rest here, start at 0 plus a pair. Hit OK. Our alignment tools geometry dialog box comes up. There's a lot of things in here. We're going to get familiar with some of it, a lot of ways to edit geometry and float and fix curves and delete things. And we're going to start with just one command, and it's going to be the tangent with curves. So we're going to select this, not tangent, no curves. That would just be one sharp edge to another. And we're going to start by picking, trying to make it easy for us. We're going to snap to the center of circle marked A, then B, all the way through E. We're going to skip over circles F and I. So let's see if I can figure this out. Have your snaps on. So go to your O snaps, turn them on. Check your running O snaps, make sure center is on. That's going to be critical. Hit escape. I got to start the command again. Let's go in here, tangent with curves. We're literally going to draw our initial alignment. Hit F3 to turn on O snaps. They're a bugger sometimes. You got to turn them on and off. I was mainly verifying that I have my center on. So we see when I snap, whatever you hover near, it will want to snap to. So when I hover near this circle edge, it wants to snap to its center. So I'll pick A. I'll hover, or if I go right on the center, but there's other things in here too. You get snapping, and what you snap to, you got to be very careful on AutoCAD. That's a skill for sure. You get better at it. We'll hover near the periphery of the circle, pick B, and then we will pick, I believe it has to go right to C. Yes, it did. Center. It's putting in a curve. Center, D, E, center. That's the center O snap E. And skip F and I. So I did that. I skipped F here and I skipped I here. Okay. And press enter, and we have that alignment initially created of Jordan Court. It put a couple curves in there. And this alignment style, you can see the PI comes all the way out. There's your PI grip. There's your radius control grip. This is your alignment parameter grip. This is another alignment parameter grip where that is located. Here's your tangent. So we're going to do the same thing for Madison Lane alignment. We'll say, we'll just leave this on. Cue it up again, tangent with curves. Go F, center, and F to H. F, G, you know, on this one, it's interesting. I don't want that curve. Let me hit Control Z to undo a couple times, or you can go up here to hit undo, go through view commands. Let me go back to alignment creation tools. Let me call this one Madison Court. Hit OK. On this one, I'm going to change my tact a little bit. I'm just going to say tangent to tangent, no curves. It doesn't really say much of that in the book, but that's the idea. Center, G, H. I don't want a curve here. I'll have to add a curve here later. That's okay. So I'll repeat steps 3 through 7 for Logan Court as well. Creation tools. I'm going to say Logan Court. Say OK. I got to pick my geometry. I'll say tangent to tangent. Let's just pick here to here. Doesn't really have it perfect in there. There, my Logan Court's created. I picked the alignment. There's no labels on it. I can see its name and various things here. And I drew it perpendicular. I just picked to the nodes of this geometry. You can totally regrip this. It only has, it's a straight shot. You can move it around, and I'm Shift plus right click. You can get your one-time O-snaps. And I verified it was perpendicular. You see what I did. I'll shift and right click, or you can turn it on here and you're running O-snaps. It'll stay on though. Hit perpendicular. I'm going to zoom way in. Sometimes I'm going to zoom way in. I get this symbol. It says perpendicular. That is the perpendicular symbol there. Okay, it's all good. So we're going to page 98. That is it on that. It's just saying we're laying out our first alignment. I'm going to close that. I'll say yes. Just save that for now. We're going to go to graphical editing next. So this is getting us to use temporary geometry that's drafted in a certain way to start building our alignments, snapping to, which we just did. And you saw it. I didn't add this bad boy because I didn't like having a curve here to start, but we're using polylines and various geometry I had in the drawing already to help me build my initial alignment, and that's not a bad thing. You know, perpendicular alignment to an alignment is ideal a lot of ways for an intersection road, for safety, for people to be visible when they're turning, and accessibility for easy turns. Uniform geometry, especially the 90-degree angles, they're simpler, more effective to stake out and construct. So this construction here, this curve with a 90-degree to its tangent. So this is a perfectly tangent from to the center, from this point straight to this arc's or curve center point is 90 degrees. They're easier to construct, so there's a lot that goes into it. Starting with 5.3, I'm in the graphical editing drawing now, and it wants us to start by going into Jordan Court and clicking on it just to see its grips. Wants you to get a little deeper in this. And it says click the upright triangular grip on the second curve. So look at figure 5.4. This would be the first curve. The station starts here and it goes up station this way. So this would be the second curve. It says it wants you to pick this and just kind of observe how you move. The curve always remains tangent to the radius and remains constant. So that's a good thing. So if I move that, it doesn't get this intersection, they're not interlinked, but at least it kept this geometry pure in the sense that it kept tangent to the arc. I'm going to undo a couple of times again. Let's go back to the beginning. It's just showing you the power of the grips. A lot of times you might even have a polyline drafted in here or some line work, or maybe there's a fence line here mapped, or whatever reason. You might have some construction lines you need to use to maybe move your alignment close enough to them, or you might draft something in that you have to grip to. There's a lot of ways to use AutoCAD entities to make your Civil 3D entities move to them. So that's more advanced, but it happens a lot as you design a lot of this stuff. So I'm going to hit delete. And the last one it's talking about is you can grab the tangents, the squares, and just the tangent ends, or this one here. It moves everything associated with it to remain tangent, the tangency on the curve to the north into the south. So this curve and this curve, as you move it, it maintains those. This one does a little different since you have a free end. It maintains them as well, but it creates a different tangent location in the XY. So it's just showing you can do that as well. That's it on 5.3. We're going to move to the next file, editing tools. Close this. I'll just hit yes to save that for next time. And we're going to talk a little more about the editing tools in what I just had up prior. We'll continue on talking about Jordan Court here. If we pick on Jordan Court, the textual ribbon comes up with alignment options, similar to Chapter 4 with what comes up with options when you pick a surface. This one we also can right click and get very similar things: alignment properties, alignment style, how it appears, its geometry editor, its labels we can add to it, convert to fixed geometry, various things, widening, sides, super elevation, more advanced thing that says how it slopes in different sides of it. We're going to go geometry editor here. And on the alignment layout tools toolbar, we're going to click insert PI, which is here. This is where you insert one, this is where you delete one. It's just a straight PI. And we're going to insert a PI and we're going to snap to the center of the circle marked A. So it left it there for us conveniently, and we're going to hit enter. Now I have a PI there. I didn't before. It was just a straight line, so it has an extra PI grip, which in this case is just a sharp line to a sharp line, or a line to a line. That's a PI, point of intersection. Okay, that wasn't there before. I just added that. So click back on my alignment. Now we're going to go into another area, and we're going to delete sub-entity, and we're going to click the curve at the PI marked B. So we're going to say delete sub-entity of alignment. I am sometimes cautious using this one, but it has its purpose. And now we're going to delete this out. And we're going to delete that out as well. It should look like the picture on the bottom of 103. Okay. But we're going to add a curve to it. So I'm going to say, I think I could probably hit escape to remove this. I'll hit escape. I'll end this sub-entity editing. We're going to go to, these are the curves. These are our spiral options, and here various floating line with spiral. These are different curves and spiral options. These are just different curves. We're going to go to more floating curves. And we're going to go to floating curve from entity end radius length. There's a few of these. You'd have to practice with these to get really good with them. And click the tangent near point A. And it's asking, I want to go in a counterclockwise direction. And specify a radius. I'm going to say 100, then hit enter. And then I'm going to say the curve length it wants is 100. And that's good. It's going that direction. It maintained this tangency. I should have typed 0 right away, but it assumed 0 when I said go counterclockwise this direction. Now, on the alignment toolbar, we're going to expand the curves button, and select free curve fillet between two entities radius. So let's go free curve fillet between two entities in a radius. This one I actually use quite a bit. I'll click this curve I just created, and then it's asking for the next entity. It says to click carefully this tangent. And it's asking, indicate that the solution is less than 180 degrees. And I'll say, yeah, I'll accept that. The one with the dot next to it's the default. And at this point, are we going to do a compound curve or a reverse curve? I want to say this is going to be a reverse curve. Remember, we just learned about those. And it's going to reverse back this way. So it goes this way and then reverses back. This is definitely a more advanced move here we're learning. A lot of designers don't even know how to use Civil 3D to this level oftentimes, I would say. We're going to say 100 for the radius. So I have my, keep in mind, my dynamic input on, which I like for this kind of stuff. So it shows up here, also shows up down here in my command line. So I can do in both spots and visualize it. Say 100, and then it connected the dots. So it said the direction from this entity to this entity and 100 radius, and it connected them, which is awesome. Hit enter. I'm done with that. I have a new alignment. You can see the different grips are formed, and we'll later learn about deeper edits in the alignment grid view. We open here, it opens our panorama, our old friend, and you can really dive into checking the constraints between fixed, floating, and free. Each entity, lines, curves, spirals, lengths, radiuses, this is where you can really dial them in. You can unlock them to do various things to really, there's always some things that constrain them. You can oftentimes, have it be at a perfect station start and end, but the radius can be this, but the length ends up being the odd man out and is an odd number. So there's a lot of math involved. We won't go too much into that, but this helps you dive into the math easier. And you change one thing at a time and let the other things change with it. So that's pretty cool. The geometry alignment grid view, which we have for profiles and other things too. So that is the end of that exercise. We're going to move to 5.5 now. So starting in 5.5, we're going to edit the Jordan chord alignment again using their alignment grid view command, what I just talked about. It had a little bit of a precursor for you. The pictures have changed a little bit, and I'm in Civil 3D 2020. So if I go here and select alignment, I can say geometry editor, or we can this time say right click, go to edit alignment geometry, takes you to the same spot. So this icon's changed in 2020, alignment grid view. I'm going to open that up. It looks a little different on your page 105. Let me shrink this down a little. I'm going to keep it on this screen so you can see what I'm doing. Oftentimes I'll have it on another screen with enough workspace. This panorama, I was talking about it earlier in this book that it comes up for certain things. This is one of them. And for the radius values for items 2 and 3, so your item number here, 2 and 3. This is our reverse curve, our little lovely one we just made here. This is item 1, item 2, item 3. You can also highlight, if you jump on them here, they should highlight. That's more corridors, I could be wrong. Yeah, now they're kind of working. You just go one at a time. Go slow. You can see them highlighting. It's pretty cool. Helps you visualize things in a busy area. Corridors, this is really helpful. So I'm going to go to item 2. I'm going to go to the radius. I'm going to change just the one thing. I want it now to be surgically 150. So this is where it gets really surgical instead of using grips and drafting things. Goes to 150. Same with this one. I want, because let's say I think this is a 30-mile-an-hour road. I'm like, I have my minimum radiuses for the center of the road. We're trying to set them up right now. Got them both 150 feet. And there we go. That's a little bit of using the grid view. So this is kind of component level editing. We're designing the element numerically, which is often called component level editing. You open up the numeric data and edit in this separate window, and you can click on other things through that, or you can also go into this area as well. Which we won't necessarily go into in this chapter, but it's saying it's an option. I haven't used this much. I mostly use the geometry tools to edit it. I use grips and polylines and AutoCAD drafting. I use also with a combination of alignment grid view to surgically change things. So that's what I do, and I like how the book went through that exercise. We're going to go into 5.6 now, component level editing. Let that open. This one's a little tricky. We'll start by, in our alignment layout tools, we'll go to open up the sub-entity editor. It's going to start out blank, and then we're going to say pick sub-entity here. Next, it's going to ask us to select the sub-entity, and we're going to pick the 90-degree bend at the curve here at Jordan Court. I think which one is it? Well, I guess it's the only one on Jordan Court that goes 90 degrees, so I'm going to assume it's this one. Pick just this entity. This is getting into component level editing, so one component truly edited at a time. Just this curve, item number 5. It's constrained on both sides. Okay, well, we can change some of this stuff. We could have changed some of these things in the alignment grid view, but they move things together. So this one lets us really dive into one at a time. And we want to say it's lock constraint. The only thing in this simple setting, we're just going to change one area. We're just going to call it a radius of 50. We'll hit enter. It changes just this one entity here and updates everything. So this is one element at a time, which is pretty cool. That's it basically for 5.6. We'll move to 5.7, which we're going to go into design criteria files and check sets. These help us design better. So when you're laying out a design like the center line of road or railway or a canal or any sort of thing, in this case a small local road over some terrain, how do you know what you're doing? If you're doing it right, do you have the right distances? Is it minimum, maximum, or your radius is good? There's a lot of things that dictate this. Can you have curves go back to back without any tangent in between? Various things. What's the speed? There's a lot of entities that enforce, well, maybe enforce is not the right word, that give the design guidelines of these to be followed. It could be the state you live in the United States, its Department of Transportation, aka DOT. It could be a county planning commission, in my case, Missoula County, Montana. I've done many roads for them. They have their specific standards which rely on other higher up standards, and they default sometimes to the state DOT for certain things, for roads that interact. Or it could even be something as small as where the subdivision is going to be, for example, possibly a community homeowners association. It could even be a small private property that isn't governed by any design standards, but you still want to do well in designing it. So maybe you design this road to the best of your ability with certain design criteria using state standards or AASHTO rules, whatever you need to do. You don't want to do a bad job, so it all comes into play how you do this. And the design criterion check sets help you do this better, and saying where you violated certain tangible items of your design, which will provide a warning symbol similar on the bottom of page 107, which is here, just kind of showing these little triangles that come up saying this design was violated. This curve can't go back to back or not have a tangent in between, or it's too small of a radius. It helps you to see those so you don't make a mistake to just assume. So design check set is a collection of one or more of these checks. Could be one, could be 5 of them, and it checks the curve, line, spiral, the intersections. When you apply it to alignment, Civil 3D will flag where it's not matching standards. So we're going to probably grab a lot of times AASHTO standards for those. which is an organization in America that does a lot of highways, which I'll move back to Google here, and it's the American Association of State Highway and Transportation Officials, AASHTO. A lot of nerdy engineers, nerd out on this stuff and draw things geometrically and get their slide rules out and they check it. But yeah, no, they have a lot of weight in how highways and everything's designed, and certain things get done certain ways. There's something called the AASHTO Green Book. It's literally an entire large book of geometric design, how things are laid out in various civil infrastructure. So we'll go back on that, not to go too deep down that hole, and we're going to apply some design checks. So let's open up the design check file, and we're going to click on the Jordan Court alignment here, and we're going to click on the properties in the ribbon in this case instead of the right click method, and we're going to go to this tab here called design criteria, and design speed. We're going to change this from 60 miles an hour. We're going to type to 25 miles an hour. If your metric would be 40 kilometers per hour. And we're going to check the box next to use design criteria based design. And then we're going to uncheck the box next to use design criteria file. We're going to kind of make our own in a way here. It's checking for tangency and various things. We set our speed. You can delete this out. You can add more design speeds. You can have different design speeds over different station ranges. This is just going to say the design speed is 25 miles an hour the entire length of the alignment. So let's go into here, and we're going to change this design check set to subdivision, and click OK. Let's just let it roll from this point. It's saying it is based on some stuff, the AASHTO 2011 customary stuff, and it will have some warning boxes will come up, 3 of them. So if we zoom in here, we'll see those warning boxes. It's found something wrong with our design as it checks it. We'll move to this one first to the south, and we'll look at this yellow or orangish shield, whatever color you think it is. I think it's more orange. Yeah. And hover my cursor over it, it's saying. So if I hover over it, it'll say design checks violated. My hover circle's getting in the way, but design checks violated, subdivision curve. Okay. So that tells us what's wrong, the curve. We'll click on the alignment to display its grips, which we have done. Let's zoom out a little bit and re-click so the grips are a little more spaced out. One more time. And let's click this one circular to the north a little bit. And we're just going to kind of repeat until the shield disappears. And it did in the first attempt. So if we go back, it's still gone. The tighter this curve is, I'm guessing it's a minimum radius violation. So we'll move that back up. We'll click back on. Well, it's still clicked on. We can right click and go to Edit Alignment Geometry, or also Geometry Editor. They both go to the same spot. Have to re-click the alignment. Show you both ways. Just get it in your head that that's an option. And it wants us to go to Alignment Grid View, which is our panorama detailed. And it's saying also it shows the warnings in here, which is helpful. Subdivision curve, probably too small. So, and it also bolds them, the radius where it's the degree of curvature, it's not long enough or big enough radius size. So that's probably telling us where the errors are. These are the items that have violations. So that's where the specific values, the very specific values that are causing these violations. So item 3, we'll just type in a new radius here. Oop, I had to double click it a few times. 150, that'll fix it. I don't know what the minimum radius is. It looks like 100 sometimes. So if I go 99, it probably violates it. Yeah. bad curve. I'll just say 140 that time. They just say leave this one at 50, and that's it. So it's just saying that's where you fix those. We'll move on to the last area, and we'll apply a design criteria file, and that's going to go to a more synchronized AutoCAD file. We'll go to design criteria file. We're going to dive into checking our design as we go. There isn't much difference between the design check set. Design check set, that one was more for us. It had our standards for a really specific subdivision, say in a locality like Missoula, or maybe New York City, or wherever the heck you are. This one is going to be a criteria file, a little more straight from AutoCAD, where I was showing you the design criteria is copied and modified. So it's slightly different. It's going to be using the AASHTO, the American Association of State Highway and Transportation Officials, a lot of words, criteria. So let's dive into that. And we have one warning symbol still going on, that one we left in the last file, design check set, right? So we're going to progress through this. We'll click back on the Jordan Court alignment, and we'll go back into the alignment properties again. And we're going to click the design criteria tab. Well, it already was pretty much. But this time we're going to use a design criteria file. And this file, expand this out a little bit just for this purpose, goes way deep into your C drive to an XML and extension markup language file. And your might be different. Mine's Civil 3D 2022. It goes way into here. Okay, and I was just kind of showing you that that's where that's at. And we have it selected, and we're going to uncheck the use design check set here. And now that we're using this AASHTO one, we're just seeing where they're at. There's some newer ones now that you didn't have privy to, and they updated in the last 7 years. So there's some roundabout ones in there now too. I'm just going to accept this, unclick this, and let's just hit OK. So we have a tangent, we have errors and that spot and that spot. So this design criteria file is basically just a little more stringent than the design check set we just used. It found 2 errors, or 4. So yeah, let's go to the warning symbol the furthest to the north and hover on it, not clicking. It says minimum radius violated, current radius 100, minimum radius needs to be 154. So you can see it goes into more detail, which is kind of cool. These AASHTO criteria, same thing here. So let's go back into geometry editor of the alignment by the right click method, edit alignment geometry this time, and I'll go into alignment grid view. You can see where they're violated the geometry design there in bold, and the warning triangle. So we're going to change the radius of items 2, 3, and 7 to 155. Might have to click it a few times. That one's okay. I beat the minimum radius by 1 foot. And on 7 we'll do the same. You can see the design speed of the column to right. They're all 25 miles an hour. You can apply different design speeds. It's a pretty short road though. Don't edit item 5. It says this one should remain 50. Okay, well, we'll keep that because this is a local little subdivision. We'll assume that we're going to get by with that. Probably have some signage here warning people not to go off the road. So that's about it on this. We've learned a lot about the designs at the end, and we understand a lot more about alignments, their purpose, how to create them, how to modify them, deeper edits, and creation, especially when we made this curve here. That was pretty wild. There's a lot of curve options in here. These straight ones are pretty easy. Making straights from curves, you could literally spend many days messing around with these, and the spirals and all the options, but we dove into just a few to create roads, and that is the end of chapter 5.